second example. In this example, we are going to find V1 and V2 in the circuit using nodal analysis. So in nodal analysis, the first step is already to select reference node and label nodal voltages. So in this problem, we're going to select this node as reference node. Then we have our nodal voltage V1 and nodal voltage V2. And there's nothing else that we need to define. The second step is to write nodal equations. So we have two nodes, we have two nodal equations. At a node V1, we have the nodal equation. The first branch over here, there is a current goes in, so we have -4 milliamp. And there's another branch that's leaving, so +6. And this branch that is V1 over 6. And this branch that is V1 minus V2 over 4. These current sums to 0. The second equation we have for node 2, so the first branch over here there is a current goes in, so we have -6. And this branch that has a current of V2 over 3. And this branch have a current of V2 over 6. And this branch over here that has a current of V2 minus V1 divided by 4. So this adds up to 0. So now we have two nodal equations with two unknowns to solve. So step 3, when we solve the equation, we can find V1 is equal to 0 volts and V2 that is equal to 8 volts. So if we look at the problem again, we also notice that this is a circuit with only independent current sources. It implies that we can model by inspection. If we write it in matrix form, it has a 2x2 matrix times the two unknowns V1 and V2. That is equal to the current goes into the nodes. So the current goes into node V1. We have a 4 goes in and a 6 leaving, and the current goes into V2. That is the 6 milliamp current source. And inside the matrix, we're going to follow the rules to find the entities in this 2x2 matrix. The diagonal entities are the summation of conductance of those resistors connected to the nodes. So for node V1, we have 1 over 6 plus 1 over 4. And that's it. For node V2, we have 3 branches connected to node V2. So we have a 1 over 4 plus 1 over 3 plus 1 over 6. The off-diagonal entities are the shared conductance between nodes with a negative sign. So we have the 4 kilo ohm that is shared between node 1 and 2. So we have a -1 over 4. And since this is symmetric, we have a -1 over 4 over here. After we set up this equation, we can simply solve the equation for V1 and V2. And in this problem, we should have the same answer. V1 that is equal to 0 volts and a V2 that is equal to 8 volts.